Hello, everyone. Welcome to today's session with Nancy Gariche. We are very excited to have you, Nancy. Today, we're going to talk about GitHub code scanning, a DevSecOps approach to security as code. A little bit about Nancy. Nancy is a senior developer advocate for the GitHub Security Lab, where she helps security researchers and developers collaborate and communicate better. In her spare time, Nancy co-leads the OWASP DevSlop Project and is a member of the AWS Community Builder group. Nancy was named one of the top 20 women leaders in cyber in Canada in 2021. Welcome, Nancy.
Awesome. Thank you. Well, welcome everyone, and thank you for coming. I'm super excited to be here. Sorry if you wanted to come last time, but the last minute I caught COVID during a trip, my first trip ever in 2 years, and I caught it. So thank you for coming back if you're back. So yes, today I'd like to talk to you about GitHub code scanning, a DevSecOps approach to security as code. So it's basically a short introduction to security as code and how GitHub code scanning uses that to help you write better secure repository, write better code, write more secure code by leveraging the expertise of security researchers from the GitHub Security Lab and also from the community at large. So that's a bit of the agenda for today. So as a career presented, I'm Nancy Gariche. I'm a developer advocate recently for the GitHub Security Lab. You're probably familiar with GitHub. If you're not familiar with the GitHub Security Lab, we're a small but mighty team in GitHub, and our mission is to inspire and enable the community to secure the open source software we all depend on. So really, we audit open source projects, help them secure their code, provide education, write blog posts, anything to help the open source ecosystem be more secure. And so an important part of what we do at the GitHub Security Lab is security research. I know this is a bit blurry, but it's okay. It's basically just showing an advisory because I work with very smart security researchers that are colleagues that often audit open source projects, and they find bugs. For example, in this security advisory, you can see that Alvaro Munoz from our lab discovered a high security server-side template injection. So the bug allows any user to run arbitrary Java code on the XWiki server. So during his research, he identified the exact bug in that project, in that code, and disclosed it privately, responsibly to the maintainers project. But having identified the exact faulty code pattern, Alvaro and other researchers, when they do find these bugs, they don't stop there. Now that they're familiar with the bug and the code where they found that bug, they can translate that code, they can translate that bug into security as code. And for us at the lab, we use CodeQL, and I'll tell you a bit more about that very soon. So that's the phase one, basically finding a bug and then translating it into code so that you can identify the pattern, whether it's on a specific code base or any other code base. So what is security as code? So from the Cyril.com website, the security as code is the methodology of codifying security and policy decision and socializing them with other teams. So as members of the We Hack Purple community, you've probably heard before, security is everybody's job. But how do different members of a team who work on the same project, but at different phases of the software development lifecycle and have different skill sets, how do they communicate efficiently and provide feedback to each other? And that varies on this, the number of changes, but you'll hear a lot that there's about one security professional for every 100 developers. So it might not be exactly those numbers where you work, but I think it's pretty common that there's definitely a lot more developers than there are security professionals to support them. So how does a security engineer or researcher scale efficiently when they have to work on so many projects and with so many people? So I'm not saying security as code is the full solution, but I think it's something to look at, and that can definitely be part of the solution. So just like in Alvaro's example that I presented, where he translated his security research and expertise in code using CodeQL, well, code is now something that developers understand and can action, compared to a PDF, for example, with a list of security policies from the compliance department, for example. You may have seen that in your workplace where, say you need to make sure that these things are done, but there's no context, there's a lot of information, and it's a lot of requests, but it's not very actionable. But when it's in code, we find that developers, even if they have to research it, they understand it more and they can actually action it. So what is CodeQL exactly? So CodeQL is a declarative query language that's very similar to SQL. So basically it treats your code as data, and it allows you to query your own code. And actually, it's not just about security. You can, as long as you want to use a pattern, you can use for whatever purpose you want. You can use CodeQL to find non-security bugs in a specific application, and you can do variance analysis that I'll talk a little bit later to find a bug not only in a specific application, but in a code base or multiple code base at a time. So, and there are mainly two ways to use CodeQL analysis for code scanning. You can add CodeQL workflow to your repository, and we'll see a little bit about that later, and run CodeQL CLI directly in your own CI system, but then upload the result with GitHub. But you need to use the Serif, S-A-R-I-F, format for that to work for whatever tool that you're using. So you summarize, you generate a CodeQL database that represents your code base. So now your code base is a database. Then you run CodeQL queries that are specifically designed to find different type of vulnerabilities. And then those results are shown as code scanning alert in GitHub when you use CodeQL for scanning. And CodeQL supports a bunch of languages from memory, and what I've seen lately, C, C++, C#, Go, Java, JavaScript, TypeScript, Python, and Ruby. And if you don't see, if you didn't hear the language that you're familiar with, I would suggest looking at the CodeQL website at GitHub, because we always try to improve and add new languages as time goes by. So CodeQL is the analysis engine used by the developers to automate security checks. So the developers are using that through to code scanning, but security researchers do perform variant analysis. And I've mentioned that a few times. Variant analysis, what is that? It's the, should have appeared. It's the process of using a known security vulnerability as a seed to find similar problems in your code. So again, let's go back to Alvaro's issue where he had a specific problem, but then worked on his code to make it more agnostic so it can cover more ground. It's a technique that security engineers use to identify potential vulnerability and ensure that these threats are properly fixed across multiple code base. And then for that, you use query suites, but there are default suites that you can use that are that were designed to be to provide as little false positive as possible. So that's the code scanning suite. And if you use that, it's the main vulnerability that are the most precise that you can find in your code. And there are other suites that if you want to be maybe a little less precise, but still go deeper into analyzing your code, you can use different suites. And you can also create your own. And that's what's interesting with CodeQL, is that you can create your own query that are specific. Sometimes, the vulnerability that you're looking for may not be as very specific to your code bases, and it won't be useful for the rest of the community, but it's something that's that it's good for your organization and your code bases. So creating your own query suites for your organization may be an option that you want to know. And the query language packs, you have to actually tell CodeQL and code scanning which language it can start detecting. It can detect what language is in your repository, but you can also specify which language you want to actually scan within your repository. If that makes sense. So yes, phase two, let's go back to Alvaro's bug that he found. So as I mentioned, he codified the bug, he found a specific project, but he came up with a model for that bug. But now that his query was available for everyone to see, anybody, it's now part of the community, and people can use that query and create their own, or use it as a seed again to find other vulnerabilities. And in that example, we don't see it very well, but here is Monkey Junkie. You can see here that the GitHub handle Monkey Junkie proposed a pull request for a CodeQL query that detects server-side template injection in popular JavaScript's rendering engine. So by doing that, that user amplified the original research. So they built based on the original research and made it available and useful for other vulnerabilities, for other use cases that can be used by the community. And why would Monkey Junkie do that? Well, of course, helping open source, like contributing to open source software security, is compelling purpose, and open source users are always eager to share knowledge and benefit. But also GitHub has a program that is a bit, bug bounty program that's a bit different than the traditional programs, where we incentivize the community to write these queries and find those vulnerabilities, but to eliminate not just in one code base, but a class of vulnerability that could be used in all the code base for people who are actually using code scanning. And by doing that, Monkey Junkie helped a lot of people, contributed to his rules that he shared with the community, but also went back home with about, I think it's 2,300 bounty that he got paid for his contribution. So if you dip your toe into bug bounty, into security, and like to find vulnerability, I'd really encourage you to go check out the GitHub Security Lab bug bounty program for CodeQL. And based on that, you can see how you can learn how to use CodeQL, find vulnerabilities, and maybe even get paid for the vulnerabilities that you can find. Okay. So, and the last phase, which is a never really ending phase, is yes, the code is released and it's open to improvement that by the community to either use for themselves, and if it's used more widely, then it can be shared with everyone else. So we always use those rules and make as a start and make them more customizable to your own code base. See that there's someone in the chat. I just want to make sure. Yes, there is. I'll share a link later, but yes, there are some workshops that you can take that goes through, and even Microsoft Learn has a few lessons on how to write queries, and yeah, how to write queries, and there's a few tutorials that you can find, and I'll definitely share some links before we end today. Next. So what is GitHub code scanning? Well, to me, I guess it's the phase 4, because what if you're not a security researcher or engineer? Imagine that you're a developer, right? If you're a GitHub administrator for a project and you want to make sure that the code doesn't include any security vulnerabilities or errors. It can be very time consuming to manually check your code base, especially if it's very large, but it's also, where do you even start if you don't have that security expertise? And that's, I think, I hope that I communicate that well, that's what I think is the power of security as code, is taking the expertise of security researcher like Alvaro, like Monkey Junkie, and taking their knowledge and being able to leverage that, even if you don't have the knowledge. But at the same time, because you run those scans, you're getting feedback, so that by getting that feedback, you learn and you understand why your code was or could be vulnerable, and helps you to code better. So code scanning, again, by default, natively, we'll see later it can do with something else, but natively it uses CodeQL to analyze the code in GitHub repository. And it's available for free for all public repository and for open source. If you have a private repository for an organization, of course, you'll need like GitHub Advanced Security, which is a paid product. But for open source, and if you have a public repository, this is free. So if GitHub finds a vulnerability or an error in your code, it displays an alert in the repository security tab that we'll see a bit later. And after you fix that code, then GitHub closes the alert. So you can use the code scanning to find, triage, prioritize all the fixes for existing problem in your code. And it also prevents developers from introducing new problems. You can schedule scans for certain days and certain times, and you can also trigger those scans when a specific event occurs in a repository, like a push, for example. Okay, our software development lifecycle. Again, as members of the We Hack Purple, you know that security is something that we want to address at every step of the development lifecycle. However, the code scanning part, we're really focusing at the development phase, right? And provide quick feedback at the development phase. And again, natively CodeQL, we use CodeQL when you use code scanning, but you can also use third-party tools. So GitHub has a marketplace of different tools of your choice. Your favorite tools may be in the list. It's not a complete list of all the logos right here, but you can also leverage those third-party tools to scan your code into GitHub. And they have different licensing models, depending. Some products in the marketplace are free for open source as well. Others are paid. So you definitely need to look and research every single tool and make sure that it is what you need. And even if they're all static analysis tools, they may be a bit different in their objective and what they're trying to achieve. So they're not all made equal and they don't have all the same purpose. But it's a good idea to go see what they can do in the offer that is out there. Okay. I recommend that organization use code scanning in addition to another DAS or SAST tool, or might using more than one cause a conflict. The recommendation is often to use more than one and two, not too many to create too much noise, but more than one to get enough coverage. And what I've done in a program, an RFSET program back in the government, when I was in the government, we would use an open source tool that we had the license to use, and a paid tool as well. So we had, without doubling our costs, we had different, like a second opinion, different coverage, different explanation of the vulnerabilities found, without being overwhelmed by all the results by adding too many tools. So that was our best practice, to use an open source tool that was free and to use a paid tool. Okay. So also other static analysis tools often are in a serif format. Serif is SARIF. So the serif format that all these tools use can be uploaded into the GitHub platform and can be used by code scanning to give you your alerts if it finds security issue in your code. Xavier isn't saying his answer. Okay, so if you want to add CodeQL workflow to your repository, it's actually pretty simple. You go into the GitHub to github.com and navigate to the main page of your repository and use your repository name and click on security right here. And from there, you'll see the code scanning alert and click on set up code scanning. And in the Get Started with Code Scanning section, you'll see click set up this workflow on CodeQL analysis workflow. So right here. So workflows are only displayed if they're relevant for the programming languages detected in the repository. So the CodeQL analysis workflow is always displayed, but the setup this workflow option is only enabled if CodeQL analysis supports the language present in the repository. So to customize how code scanning scans your code, you'll have to edit the workflow. But generally, you can the workflow that is given by default, you can commit and it would without making any changes to it. So you can configure your GitHub scan to code in your project for vulnerability. You can, as we discussed earlier, you can run code scanning on GitHub using GitHub Actions or from your own continuous integration CI system. And before you can configure code scanning for a repository, you must set up code scanning by adding a GitHub action workflow to the repository that we've seen edit earlier, and that is there by default. You don't need to edit this workflow. However, if required, if you have specific needs, you can customize it. So, for example, you can use the analysis workflow to specify the frequency of the scan, the language and directories that you want to scan, and what CodeQL code scanning looks for in your code. You might also need to do the CodeQL analysis workflow if you use a specific set of commands to compile your code, because CodeQL analysis is just one type of code scanning that you can perform on GitHub. The GitHub Marketplace contains several other code scanning workflows, as we said. Okay. So as I was saying, you can configure frequency. You can also determine if you want to trigger it from a scan or a push or a scan on a PR. And then commit your changes. So by default, only alerts with the severity level error of security level, critical or high, will cause a pull request to check failure, but you can actually decide what the level, which level you want to decide when to stop a pull request. So pull request failures do not stop code scan, but they represent a blocker when trying to merge code. You can find the list of pull request failures in the code scanning alert tab under the security tab of your repository, and you can change the level of severity and severity that will cause a pull request check failure in your repository settings. So here's the setting, and right here in security analysis, sidebar. Then right here, select the level of severity that you want to create a check failure for. Yeah, in the code scanning section. Okay, you can also, like I was saying, adjust the code scanning schedule. If you use the default code scanning analysis workflow, the workflow will scan the code in your repository once a week, and in addition to scan triggered by events. So by default, like the workflow that we see here, it scans every push to the default branch and the protected branch, and every pull request to the default branch. And the branch of default through the cron here, you see every Monday at 1420 UTC, UTC time zone. So these are basically the benefit of security as code, right? So you have automated checks to enable self-assessment, and you're using a language that developer can understand and therefore encourage collaboration and boost morale because they actually know what they're doing and understand why they're being stopped and getting feedback instead of getting feedback that they cannot action. And so definitely makes audits and reviews easier. And I'd like to end my presentation with a story that sounds a bit out of a science fiction book, but that is very real and a good example of the use of CodeQL and code scanning. So about 10 years ago, I don't know if you remember, but when NASA Curiosity rover was about to land on Mars, and NASA engineers, after performing a late code review, discovered a critical bug in the control software that would likely prevent the opening of the parachute landing. So the pseudocode that you see here on my screen explain the bug in C. So even if the parameter of a function is declared as an array of size 12, nothing prevents you to pass an array of any size as an argument of the call. So this is possible in C. So you can pass an array that is shorter, and in this case, the result is unpredictable. And the first 3 items that we're going to read real coordinates for the language, but then we're going to start reading memory and some data that is in the stack and some garbage data that can lead to a crash, but not just a software crash, the actual crash of the Curiosity rover on Mars. And that's not good news. So the NASA engineers didn't just fix that instance of the bug. They wrote this piece of CodeQL code that you can see on the right of the screen. And the small query that is looking for a discrepancy between definitions of a function and its invocation. So by building this query and running it on the whole Curiosity row of code base, they were not only able to fix the particular bug that they found initially, but found different variants and up to 30 variants of this code within the code base. So again, that shows you the power of security as code and how code scanning is actually leveraging that expertise. In this case, the bug were patched mid-flight and deployed remotely to Curiosity rover, but that's pretty late in the life cycle. So Curiosity landed safely on Mars, and that was a great use case of CodeQL. But the great news is that later, NASA sent another robot to Mars, and Perseverance rover, and this time they did something a bit different. They learned from their past experience and shifted security left. They started earlier, moved their security activities to the beginning of the life cycle. They integrated that CodeQL from the beginning of the development of the software, and they integrated that into the pipeline using GitHub Action. So why I wanted to finish with this example is to, yes, I showed you the use of GitHub Actions and how you're leveraging the expertise from security researchers and community with the different queries that are already built. But I also want to make sure that you know the benefit of knowing your own code base and being able to customize the queries and leverage code scanning and your own expertise of CodeQL to scan your code in a way that that might not be useful for other code bases, but to you. So using the default queries, but also knowing that you can create your own. So I hope this was helpful and that it encouraged you to look into code scanning, and also eventually into the CodeQL queries and creating your own and getting more familiar with your own code base. Awesome. So I think that brings us to the end. And so I'd like you to, there's a link to the GitHub Security Lab website and the handle of our Twitter account. So please feel free to reach out and to check out our documentation for anything CodeQL and code scanning.
Awesome. Thank you so much, Nancy. That was so informative. I know that our participants are already saying that it was incredibly helpful. I'm curious, do you have a couple minutes to answer some questions?
Yeah,
if there
absolutely.
are, okay, good. Okay, so if anyone has any questions, please put those in the chat. We'll hang out for like a few more minutes. But again, thank you so much. We have some feedback that Mark loved the story with NASA. I think that was a great use case as well. Just good stuff.
Yeah, it's a story we like to use. It's a cool story to use, and it really illustrates the point of what you can do for your own code base, and not only use it for a specific part of your code, but for your entire code base in different scenarios.
I had a question for you, and I know you went over it briefly earlier, but I want to just review that. And that is how can we get involved? How can we use this? Like, are there tutorials? Like, can you tell us more about that?
Yeah, I think maybe I should share a link with you that you can share with the audience on different tutorials and the documentation this. But really the most simple way to get started, and that you'll see it right away in your GitHub repository. There's a security tab, and you'll see code scanning, and there's some kind of wizard almost that drives you through it, and just using the default options will get you started. And but it's always good to, and it also links to the documentation, so if you want to customize it, you can go through the documentation and see that as well.
Beautiful. All right, thank you. That's good information to have. It sounds like just using those defaults will get you very, very far.
Yeah, we'll get you started, at least. Yes, but yeah, again, encouraging to use a default, to start with that, but to have the curiosity to look at those actual queries and see how you can make them better for your own code bases, and get familiar with CodeQL. Because if you know the language, it's a lot easier to learn the CodeQL that matches your language.
Awesome. Yeah, that sounds really fascinating, that CodeQL concept. I was like, what?
Yeah,
it's amazing.
Yeah. And my background initially is in compliance, right? And I totally could relate to like the example of us, and it was me at the time, like taking a bunch of security requirements and giving them to developers, and make sure that your code does this and does that, or it doesn't do that. But like a PDF or a list of requirements is not really helpful. So and CodeQL, and speaking that to them with their love language, a language that they actually understand and that they can do something with, is definitely moves the needle forward. And also I touched on it as well. It just empowers them to understand, like there's an education purpose as well. Like those alerts are useful and have advice, and they are learning by going through those alerts and being able to build their own queries as well.
We have another question in the Q&A. Mark would like to know, if there is a programming language not available, then are developers able to request GitHub to consider including it, or is there some specific process?
I know that they're always working on including new languages, but I don't know if there's a process to ask specific to make that request. I don't know, there's Xavier in the chat if he can answer that. That would be helpful. But I know that we have requests for different queries, but I'm just not sure of the request process of how they actually make an order for those feature requests. But I would definitely like keep an eye, like even Twitter accounts with the GitHub blog, keep an eye on that, because things change all the time.
Very fair. Okay, are there any other questions? All right. Okay, well, with that, Nancy, I just want to say thank you so much for your time and for sharing your knowledge. This was a lot of fun. If people have more questions for you, can they just ask you on not GitHub, gosh, on Twitter at this handle?
This is actually my GitHub handle, but I am on LinkedIn, so feel free to connect. My name is Gariche, you'll find me, and feel free to send me a note.
Sounds like a plan. Okay, thank you so much, Nancy, and thank you to everyone who came, and we will see you next time.